The first and foremost thing is the earth electroresistance. Many people will be asking what will be the suitable earth electroresistance for this kind of applications. So first thing is we need to understand what is this earth electroresistance. So if you take this resistance as an example, so we might have come across many resistors in electronic circuits. So this will be the symbol for this resistors. So the resistance of the particular material which we are considering is called as ohmic resistance. So the ohmic resistance is the resistance of all the bodies. So this is a resistor is a compound. So if you take any conductor as an example, so resistance is the property of the material to oppose the flow of current from one end to another end. So if the current is entering into this point, so if the current is traveling through this conductor will be providing some opposition. So that is called as ohmic resistance. So resistance offered by this material to the current flow from one end to another end, the same material. So here the entire conduction is taking place on the same material only. So that is called as ohmic resistance. So there is one more resistance called electrolytic resistance. So everyone might be aware of this battery and cells. So cells are the fundamental component of any battery. So this is how a cell will look like. Earlier cells, that is a primary cell will look like. It consists of two electrodes, and these two electrodes will be inserted into a conductive material called electrolyte. So the electrolyte will be a conductive material, and these two electrodes will be provided. One will be positive, another one will be negative. So in electrolytes, so in this kind of assembly, the flow of charges will take place from one electrode to the another electrode in the conductive medium. So here the conduction is taking place from one medium to the another medium. So this kind of resistance involves the conductor, that is resistance property of the material, that is electrolyte as well. So this is how the earthing is also happening. In earthing also, the conduction is taking place from this earth electrode to the soil. So here the conduction is taking place from this earth electrode into the soil. So conduction is taking place from one medium to the another medium. So since the conduction is taking place from one medium to another medium, the resistance of the earth electrode will be electrolytic in nature. So we cannot consider the resistance of the material. So here the most important medium is the resistance of the medium surrounding the electrode. So in our case, the electrolyte is the soil. So based on the resistance of the soil, the conduction will be varying. So resistance of the soil is the most important parameter in the earth electrode resistance. So here we are considering the electrolytic resistance and we are not considering the ohmic resistance. So the material of the earth electrode does not play a huge role in earth electrode resistance, whereas the soil resistivity plays a crucial role. So which means if I use the copper earth electrode, so I am using the same copper electrode of 3 meter length. So if I install this same copper electrode if in a soil condition of 4 meter 40 ohm meter, and if I install the same in another soil condition of 400 ohm meter. So here the material is same, the dimensions are also same, but since the soil resistivity is different, the resistance of earth electrode will be very much higher in the soil condition of having 400 ohm meter, because the resistance which we are discussing in earth electrode is electrolytic in nature. The electrolytic resistance mainly depends upon the resistance of the surrounding medium and does not depend upon the resistance of the material. So even though if I provide the same copper earth electrode with the same compounds, then if the resistivity of soil is different, then definitely the resistance of the electrode will be different. I cannot achieve the same resistance value which I achieved at the 40 ohm in 400 ohm, because the soil resistivity is the deciding parameter in earth electrode resistance. So if you take this earth electrode resistance, it consists of three parts. So the first one is the resistance of the materials, and second one is the contact resistance of soil and the earth electrode, and third one is the resistivity of the soil. So here, if you consider the length of this earth electrode, along the length only the conduction will be taking place, but all the conductors will be having very low resistance. So if you compare these three parameters, the first two parameters will be negligible. So we won't consider the first two parameters, and mainly the earth electrode depends upon the soil resistivity alone. So the soil resistivity plays a critical role in the performance of the earthing, and it is not the material. And the soil resistivity depends upon the moisture and salt content on the soil. So if the soil has very good moisture, then the resistivity will be little lower. If it is a dry condition, the moisture content will be very much lower. So if we are measuring this earth electrode resistance or performing the soil resistivity measurement, then we should do this measurement only on this dry period, and we should not perform this test on the wet conditions or rainy seasons, because the resistance value will be reducing than this normal value because of the moisture content. So whenever we are performing this testing, we should always performing this testing on this dry conditions, because the soil resistivity and resistance depends upon the moisture value. So if the moisture is higher, definitely the resistance will become lower. So these are the two factors which has some effect on the soil resistivity and the